I'm the only one.
All right, so we got 2.3 today. 2.3, it's a lot of postulates. Okay, there's 7 of them. And so hopefully you copied them down. If not, you're gonna be scrambling to get these down. On the homework, they are gonna ask you to refer to these by name. Okay, so you're gonna be answering some questions and you're gonna have to give the correct name of these postulates. In terms of the quiz or the test, I'm not gonna ask you for the names of the postulates. Okay, we'll talk tomorrow about what do we have to know from this section for the quiz. For today, for tonight, you're gonna have to know these names, you're gonna have to know what they mean. Okay, that's what our notes are for. So please use those notes while we do the homework. Okay, so we need to walk through these 7. We're gonna talk about them. We're gonna talk about why they are the way they are, what we can say about it. Some of them are gonna be very common sense. Okay, some of them we're gonna have to think a little bit deeper on, but some are gonna be very common sense. 2-point postulate, our first one. Through any 2 points, there exists only one line. Okay, exactly one line. Means we cannot draw a second line through those 2 points. Because if you try, right, a line is a straight line. So if you try to draw something else that goes through those 2 points, it's not going to be a straight line, which is not a line. So that doesn't work. This is why we can name any line using any 2 points that are on the line. Because those 2 points signify the one specific line that goes through it. Okay, so we have a 2-point postulate. The next one is the line point postulate. Line point postulate says through points A and B, there's exactly one line. That line contains at least 2 points. So the postulate itself says a line contains at least 2 points. Okay, which, yeah, we know. How many points does a line include? At least 2, right? But really an infinite number. Because you could have points all along that line and the line goes on forever. So line point postulate just allows us to say, if we have a line, we can put points on there. There are at least 2 points that we can name on that one. Okay, not necessarily one that we're going to use a whole bunch other than today, but it's there. Okay. All right. Questions on the first 2? Okay. Recap those first 2 with somebody. What are they saying?
Number one.
It's kind of like opposite. It's just not a line. Yeah.
All right, next one. Line intersection postulate. We've talked about intersection before being the set of points that two figures share or have in common. Line intersection postulate tells us that if 2 lines intersect, then their intersection is exactly 1 point. Okay, so if 2 lines intersect, 2 lines don't have to intersect, we know that. But if they do intersect, they will cross exactly 1 time at 1 point. You can't have lines that cross multiple times because then they're not lines. So they cross exactly at 1 point. Okay. And then we get into talking about planes. So the first one with our planes is the 3-point postulate. And this says through any 3 non-collinear points, there exists exactly 1 plane. This is the reason, guys, this is the reason why we can name a plane with 3 points, but those 3 points cannot be collinear. Okay, this is the reason for that. So let's show why. Sorry, you guys might be on screen here. You guys hold up. I need 3 of you guys to hold up the pencil for me. Close to
That's
yourself.
4.
Just these 3. Okay, so if we make these, can we see it? If we make these here, sorry, that's stretch, right? Those are 3 non-collinear points. Here's a plane, 1 specific plane that lands on, right? If we have 3 different collinear points, there is still 1 plane that can land on them. Now put them in a straight line. So now if they're in a straight line, we could have this plane, this plane, this plane, this plane that sit on those 3 points. That's why we can't name this plane using those 3 collinear points, because that's not the only plane that those 3 include. So that's what this postulate is telling us. That's the reason why we have to name it using 3 non-collinear points, because that specifies one specific plane. Otherwise, if they're in a straight line, it could be an infinite number of planes, including that line. That's a 3-point postulate. Plane point, just like we had line point, we have plane point. This just says a plane contains at least 3 non-collinear points. It's basically going backward on the one that we just talked about. So if we have a plane, then we can name at least 3 non-collinear points on it. Okay, that's pretty straightforward. Any questions on those last 3 that we just talked about? Line intersection, 3-point, or plane point? Okay. So we got 2 left here. Just like we had line point, plane point, now we have plane line. And this one tells us if 2 points lie in a plane, then the line containing them lies on the plane. And this is, I like to think about this like a piece of paper, right? Piece of paper is your plane. If you have 2 points that are on that piece of paper and you draw the line that connects those 2 points, that line is also going to be on your piece of paper. Again, they're postulates. These postulates make sense. They're common sense. They're things we just accept without having to prove them. So if 2 lines are on the plane and we draw the line that connects them, that line is going to be on the plane as well. Then our final one talks about plane intersection. And so if we have 2 planes that intersect, their intersection is a line. And we talked about that last chapter. All right, we saw that on the test on one of our questions. Where it has to be a line, it can't just be a point. And that's like the ceiling and the wall, right? They meet at that line. So a lot of postulates to know for tonight. And again, that's why we have our notes so that we can refer back to them. We know the names and that kind of stuff, at least for tonight. I want you to recap all 7 of those with somebody, please. All 7, talk to somebody about it.
The first Oh, yeah. There's any through any over time. If there's 2 points that were played, then it is like
Okay, here we go. So now that we've talked about all these postulates, we got to figure out what's Big Idea is going to ask us now, right? How are we going to use these in the homework tonight? And it's going to be a few different things. Going to start something like this. Don't mind the kid that's just standing there.
What is he doing?
He's just hanging out.
It's like, hey, I'm in an algebra textbook.
I mean, it looks even weirder when I cut off the rest of his body and it's like floating there. I know.
Hey guys, it's dead. No. Yeah.
All right, here we go. So what they're asking us to do here, bye guys. What they're asking us to do here, state the postulate illustrated by the diagram. So we got to figure out which of those 7 is being shown with this, if that, and then this, right? So raise your hand, tell me which postulate is being represented here, okay? That is line intersection, right? They're showing 2 lines intersect, and then they very specifically show the point of that intersection, okay? So that's the sort of thing that we might see. How about B here? Actually,
Plane intersection.
plane intersection postulate, there you go. 2 planes intersecting, intersect at a line. Great. So that's the sort of thing that they're going to show for part of it. And then another part is going to be something like this, right? We're going to start seeing bigger figures, okay? More intense things, lines. We've seen some of this stuff already, but we are going to see it again today. And we're going to talk more about what can we assume, what can't we assume, that sort of stuff with those pictures. In this one, they want us to use the diagram to come up with examples of plane point postulate and plane line postulate. So looking in your notes at what those 2 postulates are, talk to the person next to you, how does this represent it? Or how can we refer back to this picture and talk about that postulate and the other one? Can I talk someone?
That is 3 points.
Okay. And then,
Yeah, like the. But like 2 of them can be at the same one.
Okay, so. And then it's like.
That's.
And that's. Line that line in.
Yeah.
Line on that. No, actually, no, he's not point. Oh, no.
All right. Here we go. Plane point postulate. How would you refer to this diagram using the plane point postulate? What do you say? What is that postulate? Plane point. Yep.
There's 3 points of the.
What points would they be? There you go. Points B, A, and C are on plane P. There you go. That's what they're looking for. Okay. How about the plane line postulate here?
There's B and A and then.
So B and A are on that plane, and then we would say that line, we would say, so line N is also on that plane. Yep. So B and A are on plane P, so line N is also on that. So something like that is probably gonna be more of a multiple choice. It's not gonna be a type it in, it's gonna be which of these represents the plane point postulate. And you're gonna have to choose the wording that actually works out. All right, so we got that. And then we're gonna do a little bit of drawing today. So here's our direction. I want you to sketch a diagram showing line TV intersecting segment PQ at point W so that TW and WB are congruent. See what you can do. Once you have it drawn, double check and look at all the information there and see if it makes sense.
I don't have a red pen.
Once you think you have that diagram, show somebody,
This one.
see if they agree.
Yes. Thank you.
Awesome.
Oh, wait.
What's this?
Yeah. I have.
Pink is so as time goes on, you know what you can do?
Okay, you can just take your yellow out of it, but like, we're just gonna add the to your
I don't know if you can take, technically, orange, but I don't think you can take out. Unless you actually want it.
All right, here we go. Here we go. So a couple things to point out. Yours should look something like this. It should look something like this. The line, TV, it's gotta be a line, so you gotta have arrows on the end of TV. Okay, you gotta have arrows on the end of it because it is a line that we're talking about. It is a segment PQ, so no arrows on P and Q. P and Q should be the endpoints of that. They intersect at W, and we know that W is the midpoint between T and V. So wherever you put the points T and V, W should be equidistant there. It does not say anything about it having to be perpendicular or anything like that. It does not say anything about P and Q being equidistant, so you could have it end right here at P, and that's completely fine. Because it does not say that W is the midpoint of QP. Right, so we just need to make sure we have the information provided. The rest of it we can kind of play with, and we can do whatever we want. As long as we've got the line, we got the segment, their intersection point, and the fact that W is the midpoint there. Okay. So something like this, again, would be a multiple choice or something, and it would ask, it's going to show you a picture, and then it's going to ask which is the best description of this picture. So it's not going to give you like 4 different pictures. It's going to give you one and then ask which sentence works. Okay. So a little bit different of a vantage point there. All right. The one vocab word that we have, I guess it's a vocab phrase this time, is line perpendicular to a plane. Okay, so this is not technically a postulate. It's more just information that we need to know. A line is perpendicular to a plane if and only if, remember we see that if and only if in the definition, it's a biconditional. If and only if the line intersects the plane in a point and is perpendicular to every line in the plane that intersects at that point. That's a lot of words. Okay, that's a lot of stuff. Basically what it's saying, guys, is if this line T is going to be perpendicular to the plane, it's got to be perpendicular to any line that's drawn on the plane that goes through this point. It can't just be perpendicular to one line on the plane. It's got to be perpendicular to all of those lines that we can draw through that intersection point. The reason being is, let's say that we have pretend this is a straight line. Let's say we have this line, right? And I want to have this line be perpendicular to this plane. It's not enough just to say that it's perpendicular to that line, because I could have this perpendicular to that line here. That's not perpendicular to the plane though, right? So instead, if I have 2 lines that cross, I got 2 lines that cross, now it's got to be perpendicular to both of them. That's going to force it to be sticking straight out. That's going to force it to be perpendicular to the entire plane. So it's not enough just to have one perpendicular symbol. It's got to have more than one, because that's telling us that it's going to be perpendicular to the entire plane. And it's kind of a hard thing to visualize sometimes, because you're looking at a 2-dimensional picture, but you're thinking in 3 dimensions. But that line T is going straight out of that plane. It's not tilted up like it kind of looks. Okay? It's kind of a weird visual concept. Okay? So that's just one of those things that we need to be aware of when we look at a figure. Is it actually perpendicular to the plane or not? Okay, and all that being said, I'm going to throw this diagram at you, a bunch of statements, and you got to figure out which ones can be assumed and which ones cannot be assumed. Okay, talk person next to you. What do we know for sure? What do we know?
That's true. EBD are not collinear. A and B is pretty easy. No, it's not. Oh, it is. It's true.
That's
No.
I don't know.
No, this
Yeah, I think that's because there's like a right and everything. C, W.
Where's true.
My guess no, yeah. Fourth one is right because
Yeah, it's like.
I know this.
All right. So we're gonna say either yes, we can assume it, no, we cannot assume it. Whether or not it's true, it's whether we can assume it or not. A, B, and F are collinear. Yes, that's good. We can assume that. E, B, and D are collinear. No, we cannot. They might be, there might be a line that we could draw in that connect all three of those points, but it's not there, so we cannot assume that. So we cannot say that those are collinear. AB is perpendicular to plane S. This is actually yes. I know we just got done talking about if something's going to be perpendicular to a plane, we have to have it perpendicular to more than one line. This box is not showing it perpendicular to a line. This box is showing it's perpendicular to the plane itself. Okay, I know. So it's perpendicular to the plane itself because it ends on the plane, doesn't end on another line. So this is good enough to say this is perpendicular to the plane itself. Okay, so that one does work. That works. Line CD is perpendicular to plane T. False. We cannot say that. It probably isn't anyway, but there's no marking or anything, so we can't say that. AF intersects BC at point B. Yeah, absolutely. We can say that. Okay, good. All right. Last thing that I want to talk about. Last thing. I want you to think about a time, and everybody's had this time, where you have sat down on a chair or a stool or something and it's been wobbled, right? Everybody's had that, right?
Yeah.
Or it just kind of wobbles back and forth. How many legs did that stool or that table or that chair have? 4.
2.
4. Can you have a 3-legged stool that wobbles back and forth?
No.
Why not? Talk person next to you. What did we talk about today that shows us that you cannot have a 3-legged stool that wobbles?
I don't know. Single pillar. Yeah. What if I said on the
All right, here we go. So on here, for that answer, right, for what we're talking about, if you have 4 legs, one can be shorter than the other 3, and what's actually happening is your chair or your stool is bouncing back and forth between 2 different planes. One with 3 legs here, one with 3 legs here. It's going back and forth. Okay? If you only have 3 legs on that stool, it doesn't matter if one is shorter than the other. Very awkward for me to do this. But it doesn't matter if one is shorter than the other. It's always going to sit flat because there's one plane that it's sitting on. If you make one shorter, sure, that stool is going to tilt a little bit, but it's still going to be flat on the floor. So it's not going to wobble. Okay? So, well, it's still not going to wobble. If you got 3 legs, it's not going to wobble back straight. If you make it out of 4, there's a chance that it's going to wobble back and forth between those 2 planes. Okay? What if? 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 That's all I hear from you guys. What if? Okay, any questions about it? All right, that's it. Go ahead.
So what if China